Okay? So let's now proceed with a sample project. No? Ito yung parameters. So mapapansin nyo, ito yung zoning natin sa NSCP. We have two zones, Zone 4, Zone 2. Okay? Yan. So yung Zone 4, actually ang ibig sabihin niyan, yung PGA or peak ground acceleration is 0.4 G. 0.4 G. Then itong Zone 2, ang peak ground acceleration ay 0.2. Okay? So ibig sabihin kung meron kang ground motion data from say pivots, no? 'Di ba ito yung typical ground motion, no, na nare-read ng ating mga accelerogram. Yeah. So PGA, that means peak ground acceleration. Ang value niyan is about 0.4 G. Okay? Yan po yung ibig sabihin nun. While itong zone 2 is 0.2 G. Okay? Okay? So, syempre, yan pa lang yung ground motion, 0.4 G, yung pinaka-acceleration niya. Ngayon, iba pa yung response ng structure. Ano yung magiging spectral acceleration ng structure pag sinubject mo sa ground motion na yan. So, yun yung ika-capture natin next week. No? But, at least, alam nyo na yun yung ibig sabihin ng zone 4 and zone 2. Next is, kaya Z is 0.4. Okay? Kasi sa STAAD, ganyan ng terminology. No? Pag nag-click kayo ng drop-down, 0.4 ang makikita nyo. Next, importance factor is 1. No? So, anong basis ng importance factor? Ito yung table niyan. This one, yan, ito po. Yung mga standard occupancy and special occupancy structures, yan, 1 lang yung kanyang importance factor. Pero pag essential facilities, like hospital, yan, pwede mo siyang i-design as 1.5, then yung mga hazardous facilities, yan, 1.25, okay? But still, rin yan depende rin sa client, no? Meron kaming dinesign dati, 2-story lang, pero storage area na critical yung structure, importante yung loob, no, yung laman ng loob. So, sabi ng client, i-design mo siya as essential facilities. No? So, 9.5 namin siya. Okay? It depends sa design criteria na mapag-uusapan nyo with your client. Okay? And of course, kapag siyempre mga dam yan, nuclear plant, mataas yung importance factor natin sa mga yan. Okay? Pero yung mga typical residential, standard occupancy, yan, pwedeng 1 lang siya. Next is, okay, isusulat ko lang yung formula, no? Para lagi natin maalala. CVI over RTW. So, okay na tayo sa importance factor. Next is the R factor, yung ductility, no, na sinasabi ko. So, let's proceed. Next page. Yan, ito yung ating value for, this is from NSCP 2015. Oops. Yan. Take a look sa table. Meron tayong zone 2, meron ding zone 4. Yan. Say, ang project natin low-rise lang, no? Mga tip 4-story, no? Wala pang shear wall. So ang tawag sa framing natin doon is moment frame. No? Moment frame po siya. So nasan si moment frame ito? So if I use ordinary moment frame, so ito yung moment frame natin. When we say moment frame, yan yung beam and column. Walang shear wall. Okay, yan ang moment frame. Pag sinabi mong dual system, from the word dual, dalawa. No, dalawang nagre-resist ng earthquake. You have the shear wall, no, yung buhos, and then you have the moment frame, yung beam and column. Okay? So basically, yan lang naman yung typically na ginagamit, yung dalawang yan. No? Sa mga low-rise building, madalas yan, moment frame lang. So if I use ordinary, nasa zone 4 tayo, ano sabi ni code? 3.5 yung R. Pero if you check yung zone 4, NP. Ibig sabihin, not permitted. Okay? How about intermediate moment frame? 5.5. Pagdating sa zone 4, not permitted ulit. Okay? Kaya lumalabas, no? Sa zone 4, halos ito yung nagiging default value. Special moment frame. 8.5 and technically, no limit. Okay? So, special moment frame lang ang allowed sa zone 4. Or sorry, 8.5. Yeah, special moment frame na ang R value is 8.5 ang allowed sa zone 4. Well, kung nasa Palawan ka, yan, no limit ka kahit saan dyan ang gamitin mo. Okay? And you will notice yung R value niya siya yung pinakamataas among the three, 8.5. Okay, so naalala niyo yung in-explain ko kanina, yung ductility. No? Ibig sabihin, yung special moment frame due to the detailing requirements na sinet ni code, siya yung pinaka-ductile, no? Special moment frame. Kaya nga yung R value natin is 8.5. Unlike yung ordinary moment frame and intermediate moment frame, yes, meron silang ductility. No, meron silang may ductility pa rin yung mga yan. Pero among the three, ang pinaka-ductile si special moment frame. Okay? Sige, para as heads up, no? For example, sa special moment frame, nag-set si code doon ng minimum cross section ng column tsaka ng girder. Minimum width. Okay? Doon sa ibang moment frame like say ordinary, pwede mo pang i-wave yung mga yon, no? Something like that. Okay, even yung pagkakasinsen nung stirrups, no, mas masinsen kay special moment frame. Okay? Because it was found out na yung pagkakasinsin nung ties or hooks na tinatawag natin will further add ductility sa ating member. Okay? And i-recall natin yung formula, no? V equals CVI over RTW. Mapapansin nyo, siya yung pinakamalaking R, 8.5, malaking denominator. Anong epekto sa base shear? Pinakamaliit. No, pinakamaliit kasi ang laki ng denominator mo. Whereas sa ordinary moment frame, 3.5, no? Substitute natin denominator 3.5, no? Ang tendency mas malaki yung base shear sa ordinary moment frame, right? So ano epekto nun? Mas malaki yung base shear, mas malaki ngayon yung poste mo. Kasi mas malaki yung lateral force eh. Okay. However, pagdating sa detailing, no, hindi siya ganun ka-stringent compared sa special moment frame. So nakita nyo, yun yung pinaka end goal nitong lecture natin, no. Yung sa special moment frame, yes, siya yung pinakamaliit na section lalabas among the three, pero siya yung pinaka-ductile. No, mas masinsin yung mga bakal natin doon. Mas masinsin yung requirements natin doon. Okay? Kaya ang analogy ko diyan parang si Pacquiao, no? Pwedeng mas maliit siya sa mga kalaban niya, pero mas siksik yung loob niya, no? Yung mga muscles niya. So ganun din yung ductility ng special moment frame. No? Kasi tendency, maliit yung cross section natin diyan. Among the three, siya yung pinakamaliit na cross section. Pero mas stringent yung seismic detailing natin dyan para ma-achieve yung ductility na pinakita ko kanina. No? And as you notice, sino nag-dictate ng ductility? Yung stress strain ng bakal. Eh ano bang mas mahal? Bakal o konkreto? bakal, no? It's analogous, no, to the rebar, yung stress strain ng bakal, because the rebar is inherently ductile material, no? And since a special moment frame siya yung pinakamaraming amount of rebar, so therefore it follows na siya rin yung pinaka-ductile among the three. Okay? So yan, so that's R. So okay na tayo sa I, okay na tayo sa R. How about yung CACV? Okay, proceed naman tayo sa CACV. But before you get CACV, kunin muna natin yung NANV. Where is that here? Ito, nandito siya sa ilalim. Yan. So ito naman yung ating NANV. So ang ating project site is say 10 kilometers away from the fault line. And then source type natin is A. So ang NA natin ay 1. Then yung NV, ganun din, 10 kilometers. Source type A, 1.2. Okay. So alam na natin si NANV. Mamaya i-ano ko yun. By the way, nasa si NSCP. Yan. Sorry, 2010 yung madalas kong i-open kasi magaan siya eh. No? Yung 2015, ang bigat i-open. Konti lang naman yung difference nila. Lalo na sa earthquake. Where is earthquake load definition? Nasa sa mga definition? Ito pala. Yan. So what is source type A? It's a seismic source type na faults that are capable of producing large magnitude events. So source type A mo is capable of magnitude 7 above. No? Parang yung West Valley fault dito sa Marikina. No? It can generate 7.2. Okay? So parang roughly you can say na if you design your structure as per code, you are designing for a magnitude 7 above. Okay? Kindly wait po. Okay, so once alam natin si NaNV, proceed tayo sa CaCV. First, okay, nasa zone 4 tayo. Okay. Next, ano yung soil type sa project natin? So, kailangan alam nyo yun, no? That's why in a project, kailangan may soil test ka muna. And syempre, normally si geotech ang magpo-provide nung soil type. Now, when I was a geotech, sa soil report namin, binibigay na namin yan. In fact, yung lahat nga nung seismic parameter na yun, Ca, Cv, Na, Nv, kami na nagbibigay, no? Sinasama na namin sa report. Kasi kami nakakaalam ng soil test, ng soil type, no? So let's say ang soil type natin is SD, meaning stiff soil profile. Okay, so ang ating Ca is 0.44 Na. Okay, then for the Cv, SD ang soil type, zone 4, ang ating Cv ay 0.64 Nv. Okay, so at first, ano muna yung soil type, no? So andito yung definition niya. Yan. And I will say na typically, no, in most geotech report, ako in my practice as a geotech before, yung mga soil report namin halos SD. SD ang binibigay namin, no? Why? Because mapapansin nyo yung SPT value and value is medyo mataas yung range, 15 to 50. Ayan po, 15 to 50. So yan yung number of blows it takes to penetrate every 300 mm. So let's say meron kang driller, no? Meron siyang hammer, 'di ba? I-drop tapos bibilangin niya how many blows it takes mag 300 mm. So ito 'yon. If nag-average yung soil mo around 15 to 50, medyo mataas yung range na yan. Minsan man na yan, pasok na diyan ng medium dense sand. Yan. Medium dense sand, yan, pasok dyan, no? So, stiff soil profile na siya. Pero if less than 15, kagaya sa Manila, no, bandang Espanya, yan, pwede kang mag-SE, soft soil profile. And mapapansin nyo, pag more than 15 na yung blows, SC na siya, very dense soil and papunta na sa soft rock. And since medyo mataas na yan, bedrock na yung lalo na pag ilog yung sino-soil testing, bedrock na, hindi na kaya ng hammer yon, no? Nagko-coring na ang mga soil testing company doon. Yung yung bandang Makati CVD, no? May mga portion doon SC. Tapos bandang Novaliches ng Quezon City, yan, medyo matigas doon, no? SC, kaya yon, no? Pero sa Makati, after ng cash and carry, no, malambot na lupa doon, no? Yung mga bahaing portion. Yan. Yun, nag-ground improvement pa kami doon, bandang cash and carry. Kasi ibig sabihin, malambot na ang lupa. So that's the definition of the soil profile type. Okay? So you will use that here in getting CaCV. Okay? So okay, alam na natin si CaCV, balikan natin yung formula. V equals CVI over RTW. So alam na natin si importance factor, the R value, the CV, and last is the period. No, yung period. Anong formula ng period? Bezier formulas. Ito. We have two formulas sa NSCP. Yung method A and method B. And don't worry, incorporated na yan kay STAAD, no? So alamin lang natin yung definition and syempre yung theory behind. So method A, the approximate formula with the given C sub T, depende sa building mo, kung concrete frame, steel moment frame, no? You have C sub T. Pag RC, 0.0731. Then pag steel, 0.0853. All other buildings, 0.0488. So for example, nawala pala yung aking model. Open ko muna yung sa stat ko. So while waiting, minimize muna natin. Say, ang ating building ay, sabihin natin, 2, 3, 4. Okay. So let's say ang typical floor to floor is 3 meters. Yan. So how many total height niyan? 9 meters, no? So let's say RC. So 0.0731 times the height, 9, raised to 3/4. So anong period natin? .0731 times 9 raised to 0.75. Yan. So I'm getting 0.38 seconds. 0.38 seconds. Okay? Which is what? Almost 0.4. No? Roughly 0.4 seconds. So how many floors to? 2, 3, 4. See? 0.4 seconds, 4 story. No? Naalala niyo yung sinabi kong rule of thumb kanina? No? 0.1 times the number of floors. No? 0.1 times 4, 0.4 roughly. No? So nagtutugma. Okay, nagtutugma yung ating method A. No? Almost. No? How about method B? Itong method B is the fundamental period may be calculated using the structural properties. No? So pag alam mo yung structural properties, yung cross-section, no, of the elements, okay, the fundamental period may be computed by using the following equation. Actually, malito eh. Malito equation na to. No? Kaya nga, mas preferred ko yung 2010. No? Ito yung formula ng period sa 2010. Okay, ito. So, I'm going to prove na yan lang din yung yung formula natin na dinerive kanina. Ito yung formula na yan. So, see? Okay. So, ano yung formula natin kanina? T is equal to 2 pi square root of m over k. So, take note, ano ba yung formula ng what do you call that? Mass or weight. Weight is equal to m times g. So, therefore, m is equal to w over g. Which is this. Right? Yan yung w over g. No? Sinortcut ko lang. Okay, next. Itong delta I square over delta I, cancel to. So natira is delta over f. No? Yan lang natira. Okay, next is, ano yung sabi ko, this is what the softwares are using in structural analysis. Stiffness method. Sinulat ko yung formula kanina. P is equal to K delta. Right? Or in other notation, F is equal to K delta. Or K is equal to F over delta. Right? Since si K here is nasa denominator, so kunin natin reciprocal, so therefore 1 over K is equal to delta over F, which is the same here. Okay? So, what does it mean, no? Lumalabas na yung formula natin na 2 pi square root of m over k is ito pa rin, no? Siyempre, nagkaroon lang ng ibang notation, no? Kasi kinonsider niya yung lateral deformation. Okay? Kasi yun din naman yung concept ng stiffness. You will be able to get stiffness pag nakuha mo yung deformation. Okay? So that's method B na ano naman, capture din naman is TAAD. So that's it. We now know period and then we have the weight. Balik tayo dito. Oops. Where's our... Alam natin yan. And I'll open my STAAD here. Open structures. EQ1. Naka-demo mo to. How do we input that in STAAD? So, loading, definitions, seismic definition, double-click ko, no? So, yan yun. So, zone 4, 0.4. Okay, kasi nga, 0.4 G. Importance factor is 1. Take note, UBC 97 yung sinunod ko. Okay? Then, R value, yung nakuha natin, dalawang 8.5. Soil type is 4, meaning yan yung SD. Okay, so therefore, kung SC yung soil type mo, that's 3. Yan yung equivalence niya. NANV, 1 and 1.2. And C sub T is 0.0731, no? Kasi nga, RC tayo. So, ganyan lang. That's how you input sa STAAD. Okay. Wait, let me share you yung ating spreadsheet here. Base shear. Okay, send ko lang sa chat box, everyone, itong copy. Para maano nyo na, makalikot nyo na yung spreadsheet. So, dito. Yan, 10 kilometers, zone 4, i-ano nyo na lang, no? Pala, inedit ko. Okay. Save as ko muna. Zero 206. Ano ko lang, zone 4, 10, source type A, SD, importance factor is 1, yan, else, 8.5, height is, anong height natin? So, okay na to, close ko muna. Tapos sa utilities, node to node distance. 9 meters. No, 9 meters. 0.0731, no? So tama, no? Nakuha niyang formula, nakuha din niyang period is 0.38 seconds. And CACB ko is ito. So my NANB is 1 and 1.2. And this is my CACV. Okay? Mamaya, verify natin yan. So, yung weight niyan galing from the reference load Yan. So gumawa ako ng reference load here for the dead load. Okay? And then i-reference mo siya dito. Okay, so that's it. Analyze, run analysis. View output file to determine the base shear. Maximize floor diaphragm. Oops. Yan, this one. So, mapapansin nyo, no, kung i-capture ko lang yung capture ko lang yung total weight na ginamit niya. So, 4,676.18. Yun yung nakuha niyang total weight. Input ko siya dito. 4,676.18. Teka, lagay ko lang muna saglit dito. And my base shear, according to the spreadsheet, is 605.15. Yun yung nag-govern. And if you look at the output file, it's the same. Okay? The same lang, no? And you will notice yung coefficient natin is 0.1294, no? So that's about 13%, no? 13% ng weight of the building, which is 4,676.18, yan yung ating base shear. 605.15 kilonewton. So tumutugma doon sa sinasabi kong rule of thumb, no, na between 10% to 20% of the weight of the building. Yan yung ating base shear. Okay? So which is consistent with our spreadsheet here. 105.15 kilonewton. Now, if you recall, hindi lang naman yun isa ang formula ng base shear natin. Balik tayo dito. Yan. This is 2010, but if you check on 2015, yun din naman, no? Hindi nagbago. So ito yung apat na base shear formulas. So the total design base shear in a given direction shall be determined from the following equation, CVI over RTW. So yan yung lagi ko sinusulat. But sabi ni code, the total design base shear need not exceed. So yun yung maximum natin, no? Did not exceed the following, 2.5 CAIW over R. And the minimum natin is 0.11 CAIW. And additional base shear formula is 0.8 Z NVIW over R. Nandun na po yan sa spreadsheet natin. So if you check, ito yung apat na yan. So if you check yung formula, so that is 208-4 CVI over R sub over T W. Okay? 208-4. Next, 208-5. Oops, sorry. Ano ko naman, no? If you check on the formula, it's now 2.5 CAIW. CAIW over R. Yan yung 208-5. Then itong 208-6, yung minimum, 0.11 CAIW over R. And then 208-7, yung additional formula. Okay? And it turns out, ang nag-govern na formula is yung 208-5. No? Ano po yun? Yun yung Vmax. No? Yun yung Vmax. Ito. Ito yung nag-govern. Okay? So, this will be another rule of thumb. No? In most cases, no, lalo ng mga low-rise building, ang madalas mag-govern na base shear is the Vmax. 2.5 CAIW over R. Okay? So, why is that? No? Tingnan nyo, pakita ngayon natin yung response spectra. So, ito yung response spectra sa NSCP. Okay? Pakita ko yung malinis, no? Na response spectra. Yan. Okay? So, naalala nyo yung concept kanina, no? Na habang tumataas yung period ng building, in the case of high-rise, no? Mapapansin nyo, lumiliit yung spectral acceleration. Okay? Now, in the case of low-rise building, dahil sobrang baba ng period nila, na nandito sila sa region na to, no? Lumalabas ito yung Vmax. Pansinin niyo yung formula, 2.5 CA. Yan. So, yung staad natin, yung building natin, dito siya nag-fall sa region na yan. Okay? Then, pag tumaas further yung height ng building, dito na siya mapupunta. Sa CVI over RTW. Okay. Sir, wala namang R yan. So, that's it. No? Because itong graph na to, wala pa tong R. No? Kaya nga ang tawag dito is the elastic design response spectra. Now, pag inintroduce mo na yung R dito, so bababa pa yan. Say something around here. Yan. And this one is the R. Yan na yung R value. Kaya nga, ito kasi wala pang R yan. So, we can say itong value na to is 2.5 CAIW over R. Pag inintroduce mo na yung R. Ito, wala pang R to, di ba? So, this becomes CV I over R. May T pa pala to, no? CV over T, I over RW. So, see, basically, nare-reduce yung response spectrum ginagamit natin because of the introduction of or the incorporation of the R value sa ating formula. Okay? And nakikita niyo yung consistency sa response spectra, no? So, yung mga low-rise building na medyo stiff sila, no? Maliit yung period nila, most likely yan ang mag-govern. Okay, so tingnan nyo, no? Laruin natin yung spreadsheet, no? Say, taasan ko yung building, no? Gawin nating 10-story. So, ano ang typical height? 3 times 10, 30. No? Gawin natin 30 meters. Okay, tingnan nyo yung mag-govern na base shear. 450.89. It is 208-4. Yan na yung CVI over RTW. Okay, kasi pansinin nyo, tumaas na yung period niya. No? 0.9 seconds na yung period niya. So sa response spectra natin, nandito na siya sa region na yan. Okay? Kaya ito na yung naging effective na base shear formula. Okay? So at least no na capture na natin yung relationship ng response spectra sa base shear formula natin. Okay? So mamaya we'll explain further pa yan, no? Since it's already 8:05, no? Let's have a dinner break muna po. Okay?
Recording stopped.